In this video, we're continuing talking about the concepts of chapter 3, and now we are going to focus on understanding temperature. Temperature is a measure of how hot or cold an object is compared to another. It can even indicate the heat flow from an object that has higher temperature to the object that has lower temperature. And when it comes to gathering the data for temperature, we actually have an instrument that can be utilized in order to measure temperature. It is called a thermometer. We can see that the image on the right side of the slide gives us 3 different beakers that contain boiling water, but at the top, we can see that there's different words. These 3 words is actually illustrating the units of measurements that we utilize for temperature. Temperature can be measured in degrees Fahrenheit, and that is the full word. The abbreviation of Fahrenheit is here. We can also measure temperature in degrees Celsius. The shorthand for Celsius is right here. And lastly, we can measure temperature in Kelvin units, which the shorthand for it is given right here by the capital letter K. In addition, this image is actually illustrating how between these 3 different units of measurements, we have different values. What that means is that between Fahrenheit, Celsius, and Kelvin, we have equations that will allow us to interconvert each of these temperature units into one another. In this area of the slide, we can see the equations that are going to allow us to do temperature conversions. And that's one of the main skills that we are going to practice right now. Instead of doing temperature conversions by stating a particular value for a measurement and then change it to another one, I'm going to do application problems. Let's explore these. I'm now going to go over problem 3.19 from the textbook. Specifically, I'm going to do letter A. It states, a patient with hyperthermia has a temperature of 106 degrees Fahrenheit. And this is the shorthand for Fahrenheit. What does this read on a Celsius thermometer? So overall, this word problem is stating that if I have a thermometer that reads 106 degrees Fahrenheit, what we're trying to find out is what would it be if my thermometer now is in Celsius? So we need to find a conversion. We can see that there's 4 equations here. I'm now going to write letters to distinguish them. So let's say that this is equation A, this is equation B, this is equation C, and this is an equation D. Take a moment and define which out of these 4 equations is the one that we need in order to do this conversion. For this problem, we need to use this equation, the one that will allow us to go from Fahrenheit to Celsius. When I write my equation, it states that temperature in degrees Celsius is going to be the temperature in Fahrenheit, which in this case is 106. I'm going to subtract that from 32, and I'm going to divide the whole thing by 1.80. When I enter this in a calculator, it's important to note that I need to do the first operation, which is the 106 minus 32. Then the result of that, I'm going to divide by 1.80. When it comes to this calculation, let's understand that Even though my calculator display is going to show many digits, I need to round to 3 significant figures because that is how many sig figs I have in my original measurement. We have learned before about significant figures in operations. But what happens is that in this conversions, because the value of 32 and the value of 1.8 is part of the definition, then we don't take it into consideration for our final answer. We are going to base it on the number of significant figures that we are given in that original measurement. So with that, take a moment and enter this into your calculator. You should have observed that your final answer is 41.1 degrees Celsius. Take a moment and do problem 3.19, letter B, which states, because fevers can cause convulsions in children, the doctor needs to be called if a child's temperature goes over 40.0 degrees Celsius. Then we have the question that we're interested in. Should the doctor be called if a child has a temperature of 103 degrees Fahrenheit? Take a moment. Change from 103 degrees Fahrenheit to Celsius and then compare it to see if the doctor needs to be called. The next topic that we're going to talk about in this video is energy. Energy is defined as the property of matter which is manifested as the capacity to perform work. Work in chemistry means that this property is going to cause motion or interaction of molecules. When it comes to energy, we have two units that measure energy. One is joules, which the abbreviation is a capital J. And we also have calories, which its abbreviation is a small case CAL. When it comes to energy, which is what makes matter move and change, we have two large ways in which we can see it or describe it. Energy can be classified as kinetic energy, which is the energy of motion. And this energy, because it comes from movement, it can come in the form of mechanical energy, which is due to the motion of an object. Kinetic energy can come in the form of electrical energy because it's the energy from the flow of electric current. It can also come in the form of thermal energy, which is also known as heat energy, which comes from the vibration of movement of particles. We can have it as radiant energy, which radiant energy is just another word for light energy, which is an electromagnetic energy that travels in the form of waves. Or we can have sound energy, which is a type of kinetic energy that results in vibration that is transferred through an object in a wave to produce sound specifically. If energy is not due to motions, then it is considered stored energy. And stored energy is known as potential energy. This energy that is stored, it can be utilized later. And some of the forms of potential energy that are known include chemical energy, which is the energy that is stored in bonds atoms and molecules. We have nuclear energy, which is the energy that is stored in atoms' nuclei specifically. So in the nucleus of an atom. We have gravitational energy, which is the energy that is stored in an object and is defined by the object's height. And lastly, we have elastic energy. Elastic energy is stored in elastic objects. When it comes to this course, pretty much we are going to be observing examples mainly of thermal energy, chemical energy, and we are going to have a brief conversation in the next chapter about nuclear energy.